Hello everyone, today we're going to study ARP. ARP is Address Resolution Protocol, which means we resolve an address. But what kind of address we are talking about here? So that's really important to understand. Why do we need ARP? Now, first thing is there is a lot of confusion around what ARP is. ARP is a layer 2 protocol. Please understand this layer 2 of OSI, or you can say TCP/IP layer model. It's a layer 2 protocol. That means that it works at the layer 2. That means it works at the data link layer. It's really important that you understand this aspect. Otherwise, you will always be confused. So ARP works at layer 2, which means it works at the data link layer, right? But what's the purpose? What's the purpose it solves? Now that is important for you to understand. Now let's understand with an example. Let's take an example here. In this example, I take a PC, right? A PC with an IP address of, you can say, 192.168.10.3. I'm taking as a class C IP address here, so please note that. Now, what is the MAC address here of this particular laptop or PC, whatever you want to say? 00, just 60709D 4230. Now, this is a 48-bit address. Please note that. And this is a 32-bit address, 4 octets. There are 4 octets separated by dot. Okay, great. Now consider there is a router here. Okay, there is a router here. And routers, this interface, there is an interface of router which has an IP address and a MAC. So let's understand what it has. So it has an IP address of 192.168.10.1, which is a first valid host in this class C address. And then the MAC, I'm just taking an example for you to understand this. Let's say it's 00005E1B A632. Okay, so the system IP and MAC of this, and this is our IP and MAC of this laptop. Now, this laptop wants to communicate with this router on this particular interface. What's it gonna do? Let's say you have an IP address here and you want to see if the connection between this laptop and this router is there or not. So the most used command is ping. That is, you from your command prompt, you will run a command like ping 192.168.10.1, which is the IP of this particular router. When you do ping, what happens? That we need to understand. What happens is this: at the network layer of this particular PC, I'm still inside the PC, please understand. So at the network layer, there is a generation of ICMP packet. When I'll stress this word, packet. Okay? There's an ICMP packet being generated. Now this ICMP packet, when it's generated, it moves or travels towards the data link layer. When it travels towards the data link layer, which is, as I said to you, it's an LZ layer, it gets stopped. And why it gets stopped? But anyhow, first let's say it gets stopped and another protocol, ARP, gets actuated. And why does it happen? The reason is this PC should know the MAC address of the router, because at the data link layer there are two things that mainly works: the source MAC and the destination MAC. At the network layer, source IP and the destination IP. So when the ARP frame, so from or the physical layer, a frame will travel, right? So when a frame will travel towards this particular router, that frame should have a source IP and a destination IP, source MAC and a destination MAC. So source IP in this frame, when it gets generated, we know it will be 192.168.10.3, right? This one, this IP. Source MAC, of course, we know the PC is aware of the source MAC, which is 006070904280. Does it know the destination IP? Well, it knows destination IP, which is 192.168.10.2. Well, this is also known as a default gateway, just in case you want to understand what is a default gateway, which is configured in the IP configuration of this particular PC. So this is a default gateway. In our example, we're taking default gateway, same as what is pinging here. Now, what is the destination MAC here? Well, it doesn't know the destination MAC. There is no way the IP configuration knows what is the destination MAC. Now, since it doesn't know what is the destination MAC, that is where the ARP starts. It always starts when the destination MAC is unknown. What is the destination MAC? In that case, what ARP does is that it actually places a broadcast address in the frame, which is FFFFFF, that is 48-bit. Now, how does it checks that I don't have the destination MAC? How does it know? If you go into your command prompt of this particular PC, if you go to the command prompt, if you write ARP -A, you will, if it is empty, you don't find no entry found. If you see no entry found, that means it doesn't know the MAC address of this of the connected device or a connected router from the PC to this, right? From the PC to this router, the PC doesn't know what is the MAC address of the connected device, right? Now, when it reaches here, what happens? Well, it's the same thing. It's not the data link layer. It reaches at the data link layer of the router, and it goes to the network layer. At the network layer, it knows that fine. Sorry for the spell. So the network layer, it reaches to the network layer, and it says, fine, thank you. You have given me an ARP frame. I will send you an ARP, basically what an ARP response. This is another. So this frame is actually an ARP request, and this frame is basically an ARP response. Okay, that is being sent from the router to the PC. Now, what does it has? Now, look at this. This is interesting. A source IP. What is a source IP? A source IP is 192. Is a default gateway IP of the router. Okay, and then what is a source MAC? Right. Now the source MAC changes to 00005I1BE632. Okay, now this is the same as this one. And then what is the destination IP? The destination IP, since it knows that the source IP is this, so the destination IP becomes this time 192.168.10.3, which was a source IP before in the request. And this destination MAC here, in this case, will be what it will be. Well, yes, it will take it from the source MAC, and it says it's 006070904230. Now, when it reaches here, there is a when you then you type ARP-A, you would see an entry, and that entry would be 192 168 10.1, and the MAC address, which is 005E1BE632, which means that now this computer knows what is the destination MAC. This is what he was looking for. Now when he has it, it allows ICMP request to travel to the router, and the router will respond back with the response that, oh, and you will see a successful ping result in this case. So you understand that why do we need ARP? ARP is to find the destination MAC of the connected interface. That's really important. Thank you very much.